Hello guys, welcome on board. What I'll be showing you today is an LED flasher which comprises of two different LEDs, green and red. This can also be used for the police siren effect, those usual light that comes with police siren. So right now I'm just going to connect it. This is a complete circuit which I'm going to be showing you step by step on how to build. So I'm going to be connecting it right now. Good. It has been connected. As you can see, the LEDs are flashing. So I'm kind of right now adjusting the speed. You can see this is the usual police siren effect. Right now I'm going to make it faster, so I'm going to reduce it. So right now it's at the barest minimum, which is going from left to right. As you can see, green is trafficating, red is also doing the same thing. So I'm just going to increase it one more time. So this is it. So right now let's just dive into making this so you know how it was designed. So I'm going to draw the schematics for you so you can follow along with it. So let's do that right away. Hello guys, what we'll be doing right now is to design an LED flasher. Right now I have two different LEDs right in front of me. This is red and this is green. Green, red. We have the green here, we have the red here. So right now we're going to be using this to make the LED flasher. 4 LEDs on one side and 4 on the other hand. This can also be used as a police siren effect. So right now, all we need to do is to connect them. What we'll be needing for this display is an unstable connection from a fabric timer. So you can see right now, this is the LED blinking. This circuit has already been designed. If you don't know how you can do this, check the description below and you'll see the design of this circuit, how you can do it. So right now, I'm just going to start the connection of this. But first of all, for those of you who might be new to LEDs, now LEDs looks like this. This is schematic. This is positive. This is negative, as the case may be. So once the negative is passed in here and the positive is passed in here, the LED glows. But if you put negative here and put positive here, it is not going to work. This one works in forward bias only. This is a diode. It is either it is a forward bias or it's a reverse bias. So right now you will have to supply positive to positive and negative to negative. So this is the red LEDs. This is how we're going to anchor them. So right now this is how it's going to look. So this is how it's going to look. This one will be for red, and we have another series below like this. So this is how it's going to look. Here will be to ground, and here will be to VCC. Now the 5 timer plus 3 pin will come in here. So whenever there is an high, the green LEDs will glow. Whenever there is a low here, the red LED will glow because there's already a positive here. When a positive comes in here, here is negative, it won't flow through. It will go through a positive and this will glow because there's a ground here, no VCC. There's a VCC, no ground here. So whenever a negative flows in here, red LED will glow. This will glow. Whenever a negative flows in here, rather, this will glow. When a positive flows in here, it will pass through and this will glow. So either ways, as it oscillates, like it is flashing right now, when it is on, red LED will be on here. When it is off, it will be going between both, always making mistake between those. This is red, this is green. So whenever the LED is on, which means there's a positive here, the green will glow. Whenever there's a negative, the red will glow. So right now, let's just dive into making the circuit. So let's power this off first. Right now, I'm just going to connect the LEDs just like they are here. So do well to follow along. For the LEDs, how you know the positive and the negative. If you're having a new one, these are not really new. I've used them before. So as you can see, once you have a new one, the longest terminal between these two pins or the legs, as the case may be, is the positive, while the shortest is the negative. So right now, if you have something like this, there's no long one, there's no short one, both are equal. Look in between the LED where you have the glass. The smaller terminal of it is the positive, while the bigger side is the negative. So right now, I'm just going to connect. Okay. What I'm trying to do right now, I'm trying to connect per the circuit diagram we have so it doesn't have issues when it's about to work. So right now, still going to do the same here. So just trying to do the connection. So as per the diagram, VCC will go into the positive line. So let's give it a plus VCC. So we'll connect VCC here, while the other terminal, which is this, goes to ground. This will go to ground. Okay, now I've connected here to VCC and here to ground, which is what we have here. So this middle here, there's a connection between both. So I'm just going to loop out. So let's get the loop working. So Right now, I've successfully connected between here and here, between these two LEDs. So in between the middle, we're going to feed in this LED here. So right now, I'm going to bypass that. So this is pin 3 of our 5 timer. So right now, let's just connect. Our capacitor just dropped out. So let's fix back. Okay. So now let's connect our VCC and see how it works. See, it's working perfectly. So right now, whenever there is negative here, the red glows. Whenever there is a positive here, the green glows. So as you can see, both of them are flashing accordingly. You can increase the speed. As you can see, speed has increased. Now this is perfect police siren effect. Usually it's always red and blue, but right here we have green doing the job. So right now one of our LEDs is not working. Let's power off and check. So I'll power on again. See, as you can see, 4 of them are properly on. Now this is a siren effect. So as you can see, there is a flashing effect between this and this. It's fast right now, but if I reduce it to the barest minimum, you can see that at the point the red is on, the point the green is on, so it moves from left to right, right to left, as you can see. So basically this is how you design a LED flasher. You can use this for different projects. If you need to make some fanciful display on your project, probably on the rare. So thank you for watching. If you love this video, please like, share and subscribe, and see you in the next video. Thanks for watching. Hello guys, what we have on the screen is a 7-segment display using Arduino. What you can see right now is the connection on the breadboard, which was done with the aid of some resistor and 2 push button. This one here is the incrementer and this is the decrementer. When you push this once, it's going to increase from 0 to 1. Push it again, it's going to increase from 0 to 1 to 2, 2 to 3, like that. And if you're in 4 or 5 and you want to go back to 4, you can push this to decrement by 1. So if this is 9, if you push this button, it's going to go back to 8. So that is just how the system is meant to work. And if you want it to be automatic, you have to use an IC 4026 IC. It's a decade counter which you can use in relation with a 5 timer stable mode to automatically increment this without any push button. So right now I'm going to connect our system to 5-volt supply. So you can see it's on. So I'm going to zoom out a little so you can see. Now if I press one, now it's giving 1, 2, 3, 4, 5, 6, and if you use this button it's going to decrease by 1. Press again, it's going to increase like that. So 8, 9, 0, 9, 8, 7, 6. So this is meant to increase it and this is meant to decrease it. And as you can see, whenever the button is pushed, the light here on the Arduino board Uno is going to come up. Watch out for it. See it blinking. So this is just how you can easily implement a 7-segment display, counting from 0 to 9. Description, you're going to get the code and as well as the connection diagram. And you can get more of these details on my website. Thank you for watching. If you like this video, please subscribe, share, and hit the thumbs up button. Also hit the bell icon so that you get more video whenever I do an update. Thank you for watching. Hi guys, welcome to yet another tutorial. In today's video I'm going to be teaching you how you can design your own digital temperature meter using LM35. So without wasting much time, let's dive into the design. Thank you. Hello guys, welcome on board. What we'll be doing today, we're going to be talking about how to design a digital temperature meter using Arduino. So what we'll be needing for this project, basically a few components. One of them is the Arduino Uno. Second one is a 16x2 LCD display, as you can see on my hands. Here is a variable resistor you can use from 10K upwards. Here is LM35. I know it's a bit small, but don't worry. Put all the details on your schematics so you see better. So basically, this is how this LM35 looks, just like a usual transistor. It's a temperature sensor. So without wasting much time, let's just dive into doing the connections of our circuit. For the circuit diagram, you will see in the description below. So right now, I'll start first by mounting. Here is our display. So I'm going to mount it right here. So this is the display I've mounted. As you can see, these are the pins. Pin 1 to what? Pin 16. So basically right now what we want to do is to dive into the connection. So here are the connecting wires or jumper wires. You can see it's a part of the component we're needing for this, as you can see. So let's just do the connection right now. So this I'm going to break into steps for you, so it will be easier for you to understand. So for the step 1, what you have to do is to connect Arduino ground to this display here. Now Arduino ground has to be connected to pin 1 of this display, pin 5, pin 7, pin 8, pin 9, pin 10, and pin 16. Here is pin 1, here is 16. So without making any mistake, let's connect pin 1. So you can see here, this is pin 1, and here is pin 1. Connect pin 1. Now for this is going to ground. Let's use a longer one here for pin 1. So this goes to ground. But basically right now we're not going to be connecting all of them to ground because we have few ports here in the Arduino to take ground, since we are connecting a lot of pins to ground. So now let me explain something to you. So you can see on my breadboard here you have the positive line, you have the negative line. So like I said, this is the VCC line, this is the ground line. So we're going to maintain the negative line for all this. For the breadboard, if you don't understand how breadboard works, the vertical are connected together. For this terminal, same here. Then here is connected horizontally. So right now, I'm just going to go back to using the short one. So let's start with pin 1. This is pin 1. Pin 1 is connected to ground. Pin 2 is not connected to ground. Like I said, pin 1, pin 5, pin 7, 8, 9, 10, and 16 are connected to ground. So this is 1. You can count so you don't make mistake. 1, 2, 3, 4, 5. So this is the 5th one. As you can see, also connected to ground. That is that. Now pin 7 is connected to ground as well. Now pin 8, ground as well. Pin 9 also connected to ground. As you can see. So pin 10 also connected to ground. Then pin 16 also connected to ground. Now the first step has been achieved by connecting pin 1 of Arduino, pin 5, pin 7, pin 8, pin 9, pin 10, and pin 16 to LCD. So all these pins are all connected to ground. Don't make mistake about it. Now the next step is to connect our VCC line, which is our plus 5 volts. So right now I'm just going to use the red connecting wires. So for the VCC, you have to connect pin 2 and pin 15 of this LCD to plus 5 volts. So now this is pin 2 connected to plus VCC line, which is the first one. Then pin 16, as you can see here, it's connected to VCC line. Now step 2 is completed. So step 3, what we need to do right now is to connect pin 5 of Arduino to pin 4 of the LCD. So here right now we need our Arduino handy. So let's start the connection. So let's go to pin 4. Pin 4 of Arduino is connected to pin 5. Rather, pin 5 of Arduino is connected to pin 4 of the LCD. So let's go to pin 5 for Arduino. Already connected. Now the next step is to connect pin 4 of Arduino to pin 6. So right now, pin 6, we're connecting it to pin 4 of Arduino. Okay. The next step is to connect our pin 5 of Arduino to pin 11. So sorry about that. First one here is to connect pin 3 of Arduino to pin 4 of LCD. Made a mistake there. So right now we have to connect pin 5 of Arduino to pin 4 of Arduino right now will be connected to pin 6 of the LCD display. So right now, let's just start it all over so we don't get it all confused. Right now, the VCC line and the negative line has been connected. So now is to move straight to connecting the pin 3 of Arduino. So here you have pin 3 of Arduino connected to pin 4 of our LCD display. Next is to connect pin 5 of Arduino, pin 4 rather, of Arduino to our pin 6 of the LCD display. I've already done that. So next is to connect pin 5 of Arduino to pin 11 of LCD display. As you can see, this is pin 11. If you are not familiar with the pin, you can always count them to be very sure of what you're doing. So right now, the next thing is to connect pin 6 of Arduino to pin 12 of LCD. Good. So the next thing we need to do right now is to connect pin 7 of Arduino to pin 13 of LCD display. So next is to connect pin 8 of Arduino to pin 14 of LCD display. Sorry, pin 13 rather. Connect pin 8 so guys, the last step here is to connect pin 8 to pin 14 of LCD display, which is in terms of the LCD connection basics. So right now we have the pins already configured. Now we have one more thing to do, which is connecting our pin 3 to a variable resistor. So right now we have to connect pin 3 of our LCD to a variable resistor. So for the resistor, this is the variable resistor. The pin 3 terminal is going to come in through this first knob here, and then let's just mount this first properly. Now place it through the first knob. Now these two terminals, two legs of the resistor, has to be connected together. So from there to go straight to ground. So let's connect it to ground. It has been connected to ground. So basically at this point, the first step of connecting the LCD to your Arduino is completed. Now what we need to connect right now is this sensor, which is LM35, used for the temperature sensing. So I'm going to place the LM35 at this point here. Now if you place it like this, which I'm going to explain on screen for you, once it is facing this way, pin 1, this is pin 1, middle one is pin 2, third one is pin 3. So I'm going to place it just the way I'm holding it. First, let's open these legs a little. Great. Now it's been fixed. As you can see, this is it. So right now what we need to do the connection. So at this point in time, we have to connect the first leg, which is the pin 1 of this, to Arduino VCC, which is the plus 5 volt. So we'll connect the first one, plus 5 volt. Second one has to be connected to an analog input of A0. This is A0 on the Arduino board, A0 here. So the last one, which is the least, is connecting the pin 3 to ground. So pin 3 has been connected to ground. So at this point, our connection is totally complete for this project. So let's just pull this, place it behind in case of the sensing. So connection is completed now. At this point, we have to connect Arduino to PC and configure it using the code which you'll be seeing on the description of this video. So see you on the screen while we write the code and upload to Arduino. So now I'm practically connecting Arduino here, connecting it to my PC. So you can see Arduino has been connected and active. So what we need to do right now is to connect our code to Arduino by uploading it. So guys, here we are on the screen. This is Arduino IDE environment. These are the codes that will be running our program for us. First of all, let me explain the first line. This first line here is including the liquid crystal library into this in order for this screen to be recognized. Secondly is to declare the LCD pins. Now from here you see that the LCD pins are declared as 3, 4, 5, 6, 7, 8, which exactly we have on our connection already. So these are basically out to display the figures as it is using the BCD code, the binary, but you don't need to go through this right now. You can take your time to understand this if you want to know about binary. But basically this is the code which we need to get our program running. So at this point, what I need to do is check if our Arduino is fully installed. As you can see, Arduino is installed. It's on port COM3. So at this point we can upload our program into our Arduino. So right now, sorry about that, since there's an error here. So guys, right now this is bringing error. As you can see, I try to upload it, it's flagging this error, which is exactly this characters here, which is a mistake on my part. So I'll have to re-upload it again. As you can see, sketch has already been uploaded. So right now let's see our project, see how it works. So guys, our code has been uploaded. As you can see on your screen, system is working fine. First line of the LCD display, as you can see here, it's reading temperature. Then second one is reading the values. This is the temperature sensor here. So let me place my hands and see if that is going to influence the figures. you can see figures are varying and it's increasing. 34, 35, so you can see that's the current temperature of my body. So you can see, so it's 35°.57. So this is basically how you can set up your own temperature sensor. So I believe you've learned something from this. If you like this video, please like, share and subscribe. Also hit the bell icon so that next time when I upload a video, you'll be the first to know. Thanks for watching. So guys, after the connection of the LCD to the Arduino, now it's time to connect our ultrasonic sensor in order to be able to at least sense the range which we are looking for. So right now, this is the sensor. So you can see here, I don't know if it's visible enough. This first line here is the VCC. Last one here is the ground. Here is the trigger. So you can see, I don't know if you can see it. Then here's the echo. So right now, I'll just connect them. This to VCC. Then this one to ground. Then for this, for the trigger, it's going to go to pin 9 of our system, while the echo pin 10. So right now, our circuit connection for the ultrasonic range finder is complete, as you can see. So right now, all we need to do is to connect Arduino to system and program it. So let's do that right away. So guys, here we are on the screen. As you can see, this is our program. First line here is the inclusion of the liquid crystal library for this LCD display. Then from here, second line code is declaring parameters in which these figures will be declared. LCD is connected from pin 3 to pin 8, of which pin 9 is also declared as the ID for the pulse. So let's just upload the code to our Arduino board and see how it functions. Right now, code is uploading. Almost done. So here's our program uploading. Program is completely uploaded, as you can see. So right now, let's see how our work functions. So guys, our code has been uploaded successfully. So you can see these are distance or range meter. So right now it's reading about 1,000 meter cm rather. Now it's 50 something. Why it is reading that way is because it's trying to, as it's sending the signal, probably hitting every object on its path. So let's give it a direct. Right now I blocked it. You can see it's showing 7 cm. If I move this, now 12 cm. If I move further, you can see 13, 14. So I move close again. We're gonna see the screen. 4 cm, 10 cm. So right now our project is working perfectly. If you like this video, please share, like and subscribe. Hit the bell icon to get more video whenever I upload. Thank you. See you in the next video. Hello guys, welcome back. What we'll be talking about is LED chaser using Arduino Uno. So let's dive into it without wasting much time. Here are the list of components we'll be needing for this tutorial. One of them is Arduino Uno. Second one is resistor, 220 ohms or 330 ohms as the case may be. You can use between 220 ohms to 530 or 620 ohms as the case may be. Next is connecting wire, which is in the battery. Fourth one is LEDs, the green and red. Fifth one is breadboard, which we'll be needing for this tutorial. So let's dive into it. Now basically we'll need to look at the connection diagram for this tutorial. Here on the screen we have the connection diagram. What you need to do is you need to follow up with this tutorial is to make your own connection just as I have done mine on the screen. You need to connect the negative part of this LEDs all to ground, which we have done here. Then the positive side, you have to connect the 220 ohms resistor to each of the legs, and from the first one connect to pin number 9 on the Arduino Uno, second one 8, 7 respectively till you get to pin 2, which is this last LED here. So after doing all that, what you need to do is to basically go into the sketch and upload the code which will be on the description of this video. So without wasting much time, I'll also show you how you can do the connection on freezing or on your own. You can follow the process which you'll be seeing on the screen right now. So let's just do that right away. So guys, this is the connection we want to do right now. This is the LED chaser parameters we need to get it done. Here is the Arduino Uno. Here are the LEDs. These are the resistors we need, 8 of them each for resistors and the LEDs. So right now let's just do the connections. So place them on the breadboard. As you can see. So here are the 1, 2, 3, 4, 5, 6, 7, 8, which are the 8 LEDs we'll be needed for this project. So in order for the voltage not to destroy these LEDs due to the current being passed through, we have to limit the voltage and the current with the resistor. This is a 220 ohm resistor. So right now place them here the connections for the resistors are done. So what we need to do right now is to connect the terminals to Arduino Uno. The first one here is going to pin 9, so we're just going to connect here to pin 9. So second one, pin 8. So the third one, pin 7. Pin 6. Pin 5. Three, then pin 2, which is the last. Right now we're going to change color. Make it green. Is 0. Just want to change the color to green. So that is that. Then for this terminal, take it to ground. So that's that for the connection. What needs to be done now is to upload the code, and the LED will be up and running. So I'm just going to change this to black because that's the ground. So after this, we need to upload the code and see how it functions. So see you over there. So guys, this is the sketch, the code that runs the LEDs from the Arduino Uno. Here we have the declaration of the terms here, which are the pin counts, starting from pin 8. The integer pins is 2, 3, 4, 5, 6, 7, 8, 9, which are the pins we already connected our LEDs to on the Arduino Uno from our sketch diagram. So this system is just going to loop across each of these LEDs at the speed of 5 nanoseconds, which you can increase to see the visibility more clearer. But as it is, what you just need to do is to upload this code to your Uno, and the circuit should be up and running. So what we'll do right now, we'll just upload the sketch and see how it works. Sorry about that. So the sketch is fully uploaded. So let's see how our system works. So this is our system running. As you can see, the LEDs are working just perfectly well. So if you like this video, please like, share and subscribe. Also don't forget to hit the bell icon so that whenever I upload a new video, you can always be the first to know. Thank you for watching. Hello guys, what we'll be discussing in this video is basically the wiring of Arduino to a DMD board, which is the P10 board popularly called. Right now this is the circuit diagram we have on the screen. Most of you who requested for this video said you needed the diagram, so here it is. I've gone ahead to give you this. You can also find it on the Google image for this simple sketch. So as you can see, the board is numbered in this manner: 1, 2, 3, 4. It is numbered on both sides, not directly. So you have to follow it carefully from 3 to 15. Here are all grounded. As you can see, 3, 5, 7, 9, 11, 13, 15. They are all grounded. While 1, which is the enable key, is sent to pin 9 of the Arduino Uno. The second one here is connected to pin 6. Then pin 8 is connected to the, so let's just trace it so you see it. While I say it, you can get it. This is it. So pin 8 is connected to pin 13 of the Arduino Uno, while pin 10 is connected to pin 8. Pin 12 is connected to pin 11. So basically that is how you connect it to the Arduino Uno. You might be wondering, why is this circuit here? This is RTC circuit, a timer circuit, which we'll be using after this tutorial to design the digital clock, but you don't have to bother yourself about that. So once this circuit diagram has been wired, as you see it here, the next thing is to upload the code. So this is the basic code we'll be using for this display test. Basically, this is the display test here. These are the libraries we need to get this running: the SPI library and the DMD. So you have to make sure these two are included in the script in order for it to run. So here is the code. What you just need to do right now is connect the Arduino Uno, which I already connected, and the next thing you do is hit the upload button. So you can see here the upload is ongoing. Once it is done, it will be indicated it is done. As you can see here, code is fully uploaded to Arduino. The next thing right now we need to do is to connect the Arduino to the DMD board, which we're going to be doing right away. So hello guys, it's your man Webmaster. What we are going to be talking about today is your matrix display. So what we have here is a P10 display board. So we'll be using this to display our test. Basically what we'll be doing is a scroll test. I will scroll from this axis down. So here is Arduino Uno board. Here, as you can see, this is a little connection I had to do myself. It's a DIY connection. Here is the soldering. I'm going to give you this connection circuit diagram so you know how to do yours yourself. This is just done to make it easy to connect between this P10 board to this Arduino Nano board, as you can see. So basically right now what we have is the connection between here and the Nano board. I've already done the connection, of which I'm going to taking you step by step on how to do it, and even the codes which will be uploaded into this Uno to drive this circuit. I will also put it in the description below, including the circuit diagram itself, so you can follow step by step and recreate what we have here. So basically what we'll be doing right now, I'm just going to connect it. First and foremost, I'm going to be using this power supply. This is my DIY battery pack. This is 8.4 volts. As you can see, it has its own BMS inbuilt here that help to regulate discharges in this battery. So I'm going to be using it alongside the Uno. So I'm not going to be connecting to PC right now. So I'm just going to do the connection. So I'll pause it and connect it. Either ways, let's try to do that. I've already connected it. As you can see, there you go. Now after connection, took 2 seconds for this board to drive. As you can see, it's displaying welcome to Bubu Technologies. As you can see, those a bit not too clear. So right now I'm going to pause this video and use my power supply here to power this, because right now the Uno is powering this circuit with 5 volts, which I needed to get to 6 volts in order to make it very sharp. So I'm just going to pause this and power this up by connecting this to the back of this display board. As you can see here, that's the power supply point for the external power. So whenever you're building using this dot matrix P10 board, always endeavor to power it separately using a 6 volt power supply or a 5 volt that has a higher current rating. So right now I'm going to be using this box as a power supply. As you can see, let me show you. There you go. Output 5 volt, 70 amps. This can power a whole B-board of this. So let's just pause the video like I said. So we'll power it up, of which I'm also going to be trying this on this other matrix. These two here are red. So let's give it an external power supply and see if there's an improvement. So guys, I've gone ahead to connect this. As you can see, it's connected behind it. Now this circuit is on, but it's not displaying. That is because it's already recognizing the external power supply, which I already looked, because the common on this Arduino board is still engaged. So I'm going to turn on my UPS. There you go. So UPS has been turned on. So there you go. Power supply is on now. So you can see it's very bright now, and the write-up are visible enough for you to read on the screen. So this is basically how you can power your P10 matrix board using an external power supply. Hello guys, welcome back. This is another video, a continuation from where we stopped the last time. So the last time we went ahead to design this, which is a scroll board using the P10 display. So this is our board which we designed, we used for that. This is Arduino Uno, and connection is still the same. As you can see on the screen here, that's my laptop. This is the circuit diagram of what we're going to be doing in an IoT Bluetooth notice board, which can be communicated wirelessly. That is to say, this notice board information can be sent to it from an Android phone, a computer, as the case may be. So, but in this case, we're going to be using the Bluetooth terminal to explain how the information gets from the phone to this module, which is the CH05 module. This is it. It's a Bluetooth module that helps to convey the information from the Android phone down to the Arduino. Arduino processes it and displays it on this P10 board, as you can see here. So basically, I'm going to explain one more time the connection of this P10 board. Here I'm going to be combining two. In the last video we used just one for the scroll board. So this is the P10 board. This is an SMD P10 board, high quality. So now let's just start. If you turn the board, as you can see it here, this had the 12 connectors, as you can see. Now this is the arrow. This comes like this. It means this is the input, while it goes out, this is the output. So if you are to connect another board to this, it goes from this output to the input of the next one. So as you can see, this is another here. Let's see if we can turn it. That's it. You see the arrow going in. This is the arrow. This is the input for this. So as you can see, this goes from here into here. So this is basically how we're going to be connecting this. Now we are using two displays. In this case, sorry, I'm using my phone to film this, so it's going to be a bit shaky. So this is the ribbon that connects one of these dot matrix P10 board to the other. So basically, this is the input. Like I told you before, this is the arrow. It goes in here and comes out through here. Goes into this board again and comes out through here. And one way you can easily get to know the input and the output is that this power button here is at the power terminal. The input is always far from the input button. That is, this power input is always far from the input terminal of this of 12. So as you can see, it's equidistant from here, but here to here is very close. So this is the input and this is the output. But don't guess, always check the arrow. Production can vary across different company that produces this. So this is for this. For this board, I'm going to be holding it together with a magnet and a steel. So in this case, I'm going to be using this steel to hold our boards together. As you can see, it's a bit. So I'm going to be using a second one. These are high quality magnets. There you go. Now they are both together. You can easily, as you can see, can easily stay together on this. Can't really have a firm grip on it because of the recording. I'm using one hand, which is not supposed to be. So this is this for that. Now here we go. I've gotten a 5-volt adapter. Let's see. You can get that very clearly. There you go. Now it's very clear. This is it. Rating 5-volt 2 amps. It's a Cisco router adapter, as you can see, a very high quality adapter. So these are the connectors to drive these P10 boards. Arduino cannot provide the exact power you need for it, so we have to power it externally using this adapter. So I'll be connecting it just in a moment. So guys, this is the power. I'm going to mount this to this, as you can see. That one goes in there, and here is the second power port. There you go. So now I've mounted that So what we need to do is to connect the inputs of this to the Arduino board, which has already been programmed. So right now what I'm going to be doing is to flip this over. There you go. Now it's been flipped over, so we have to make sure we avoid anything that will cause a breach. So right now I'm just going to power this up and see how it works. So guys, as you can see, this is it. So I'm just going to move on. Right, so let's wait for it. If that will come up on the screen showing welcome to my world. There you go, welcome to my world. So this IoT notice board is fully completed and automated, which is ready to be deployed. So it all depends on how you want to package it for delivery. So this is basically how it is done. The circuit diagram, the code to this project will be in the description of this video, so do well to check on it. Thanks for watching. If you like this video, please like, share and subscribe. See you in the next one. Hello guys, welcome to yet another tutorial series. What we'll be looking at today is how to build a mini weather station which is capable of reading the temperature and humidity. So all we'll be needing for this tutorial are basically three components. One is the Arduino Nano, one is Oled screen. For this is I2C. You can also use the SPI, but in this case we are using the I2C, which comprises of two pins. This is your DHT sensor. This is DHT11, though you might be having the one that is having three legs. One will be the signal, one will be ground, and one will be VCC. In this case, it's the same thing here, just as in this leg here, second leg here is not connected. Let me give you a preview of it. On the int, you see there is no connection. So this is ground. This is your voltage supply, which is VCC, and this is the signal pin, which will be going to your digital logic 2 on this Arduino Nano. So guys, let's do the connection right away. So like I said, what we'll do first and foremost is to connect the VCC and the ground of each of these terminals to the VCC and ground here. So right now, let's take the ground. This is the ground. So it's here. Okay. VCC plus 5 volts. You can also use a 3.3 volts. It's a choice. Let's change this to red, and this to black. The next one will be the SDA, which is this, but let's connect the SC first. So the SCL is meant to go to A5, which is analog pin 5. So let's just do that. Let's give this a different color. Let's connect the SDA to analog pin 4. Give this another color. Wow, that should just do it. So for this is ground. Let's connect this straight to ground. This is VCC. Let's connect this straight to VCC. Let's give it a red. This a black. Okay, so this is the signal which is meant to go to digital pin 2. Let's connect it to pin 2. This should just do it. So basically this is all the connection you need. So right now what we need to do is make the connection for real, then upload our code. So at this point you just need to pause the video and do your own connection on your breadboard or on your Vero board, as the case may be. If you're going for a permanent soldering. So right now we're just going to uploading the code. So this is the code we'll be uploading. Basically there are a few libraries you need to add right here. So for this you need to add the Adafruit GFX, you need to add the Adafruit SH1106, at the same time the Adafruit sensor library in order for it to read the sensor that we are attaching to this device. So basically that is it. Then something you have to note for is the width of the screen, or the display width of the screen, which is 128 by 64 is correct. You also have to know the reset order. Here is -1. So guys, what we need to do right now is just go into the uploading of this code. So before you do that, you have to check for the board. The board here is Arduino Nano, and the processor here is Atmeg 328, which is correct. Then our COM port is 9. In your case, it might be different, and it will always be different depending. So you just have to select it. Then after that, you can do the code upload. First of all, you can verify to see if there are any errors in the code. So you just upload. Right now our code is uploading, as you can see. So once the code is fully uploaded, our screen should come up showing the current time and the correct temperature and humidity, which is the aim of this project. So project is fully uploaded, as you can see. The screen has come up. So right now it's showing 33.30 as the temperature, while the humidity is 71. So I'm just going to try and blow hot air using my blower to see if the temperature is going to change. So right now, let's practicalize that. So guys, this is my dryer which I use for shrinking my tubes for the battery packs. It works perfectly. So right now, temperature is on the heat level. Taking it away from me. Let's see if it's going to return gradually. Usually the code is meant to reset every 30 seconds. So let's watch it if it's going to drop after a while. As you can see, it's dropping. It's going down. Let me zoom in a bit so you can see properly. Now the temperature is fast going down. So guys, as you can see, it's dropping. So this is basically how you can do this. All you need are these three basic components. Do the wiring correctly, and this code you're going to be having it in the description below, so you don't have to worry. And every library will also be in the description below, so you just need to download them and upload them, and it will work perfectly. Thanks for watching. If you like this video, please share, subscribe, and give a thumbs up. Also hit the bell icon so that you get more videos when I do my uploads. Thank you for watching. Hello guys, welcome to yet another tutorial series. What we'll be discussing today is basically an Arduino clock, in which we'll be using an Oled display as a means of displaying the time, real time. I'll also be using this tiny ROTC module. This is another type I have here, but we'll be using this. So we use this because this is directly an I2C compliant. This one also works as well. We'll be using this. So as you can see, the terminals, the mesh, you have your ground, you have your VCC, the same thing here, you have your SDA, you have your SCL, so it's the same thing across. So basically what we'll be doing here is wire this up. So right now I'm just going to wire it up. So ground to ground. Okay, make that black. So VCC to VCC, make that red. Should just do. So right now we need to also connect VCC. Right now we need to also connect VCC and ground to ground of this Arduino Nano. So right here is our ground. So let's just connect this. Okay, let's just do it. Changes further. Let's connect VCC which is plus 5 volts to this. So let's just look for a way to make this a bit neat. Okay, so change this to black because it's the ground terminal to avoid confusion. Now we've had this all wired up. These three components are wired up correctly right now. Ground, they share common ground and common VCC. So right now, these will also share the same sequence. So I'll send this SCL to this and give it probably a green or something. Okay. Now let's connect SDA to SDA. Let's do it. Give it a yellow. That should do it. Now, sorry about that. I need to connect my power right away. So what we need to do right now, as the final stage of this connection, is connect this SCL and SDA to our analog pin 4 and 5. So SDA is going to analog pin 4. So right now we need to connect this. Sorry about that. Let's connect analog pin 4 to SDA. Now analog pin 5 to SCL. Okay, so let's just give them different color to differentiate them. Okay, great. That is it. So our connection is all wired up. So right now all we need to do is to upload our code to this Arduino and power our system up with 5 volts. You can connect the 12 volts through the input here, or connect the direct 5 volts to this input here. Probably just use your PC to power it after uploading your code. Leave it on. So right now our wiring is all done. What we need to do now is to move to the code upload, which we'll be doing in a moment. So right now, this is the code we need to upload to our Arduino Nano. So I'll just check, connect our system, and do that right away. Right now, what we have here. Welcome back, guys. Right now, what we have here is our wire all connected. Our system has been wired up just as we have in our circuit diagram earlier. Now what we need to do basically right now is upload the code to our Nano, which is already connected to the PC. So right now I'm just going to select to make sure our board is properly connected. It's Arduino Nano, ATMEG, then the port is some COM9, so everything is all fine. So I'll just upload the code. So now the code is uploading. Once the upload is complete, we should see an effect on our system. There you go. Code upload is completed. Here we go. Our time is working right now. So if you look at it, this is the current time right now it's having. This is the date. Today's date is 5th December 2021, and if you can look closely, this is it. So basically our code works, and this is just how you can implement a simple time and date